Welcome to Fun with Science, Engineering, and Technology. I'm Mr. Ross, and today what we're going to do is we're going to do some MCAS questions. We're really going to have a lot of fun with MCAS questions. My test experts are David and Bernard, and you guys like to take tests, don't you?
No.
Oh, no? Sure you do. They're a lot of fun. I mean, it's like a competition. It's like going out and playing baseball or basketball or something. You're really competing with the person whoever wrote the test question, right? And what they're trying to do is write a question that maybe you can't answer, right? And what you're going to do is you're going to compete against them, and you're really going to answer the question, right? So we have MCAS coming up, and what we have is a bunch of sample MCAS questions that the Department of Education published from past exams and for people to practice with a little bit. Right? So what we're going to do, these questions won't be repeated again exactly the same way, but the subject will be covered again probably on some other test. All right, so the first question has to do with some sound. And Bernard, you want to read the first question?
The figure below shows a glass partly filled with water. Grace tapped the glass with a metal spoon and heard a sound. Which action would raise the pitch when she tapped the glass again with the metal spoon? A. Pour some of the water out of the glass. B. Pour more water in the glass. C. Heat the water in the glass. Or D. Cool the water in the glass.
All right. So, what do you think? What do you think the correct answer would be?
B. Put more water in the B. Put more water in the glass.
All right. B. Put more water in the glass. Right. That's the correct answer. And the reason for that is, I know you guys haven't done sound in a long time, but what really happens is the sound waves, the higher the frequency or the higher the pitch, the shorter the wavelength, right? The shorter the wave is, right? And the lower the frequency, the longer the wave. And what's happening when she taps the glass, right, and generates some sound waves, it's just like you going out into the schoolyard and yelling at the building, which I know you do all the time, right? And you get an echo back, right? And if that echo comes back just at the right time, it's going to make your voice sound louder. And so, depending on how far away you stand from the building could actually make you sound a lot louder, right? And the same thing is happening here. You strike the glass and generate sound waves. They're going to travel down the glass, hit the water, and come back, right? And if they come back just at the right time, they're going to reinforce the sound. So what happens is this is dependent upon the wavelength of the sound, whether it comes back and reinforces it. So if you add some water, raise the water up a little bit, you make the wavelength shorter, and you're going to increase the pitch. All right, let's go on to the next one then, and take a look at this one. All right, David, this one's yours.
The figures below show a light bulb connected to the battery in two different ways. Battery, figure 1. Sorry. When the switch in figure 1 is closed to the bulb will light. A plastic ring is inserted to the socket as shown in figure 2. What will happen when the switch is closed in figure 2? A. The bulb will light just as it did in figure 1. B. The bulb will be brighter than it was in figure 1. C. The bulb will light but less bright than it was in figure 1. D. The bulb will not light at all.
All right, so let's look at it a minute. Let's analyze it, and then we'll go back and we'll see if we can figure out the right answer. All right, figure 1, it said, all right, if I close the switch here, we got a battery, we have some wires, conductors coming up to the light bulb, back down to the switch, and from the switch down here. Now the switch is open, and then this is what they call a nice switch. So if I move it down and I close it, it says this light bulb lights up and burns pretty bright.
Oh.
Right? Now, we change the circuit a little bit, and we have a battery. We still have the same conductor coming up here to the light bulb, right, and going from the light bulb. Then we put a plastic ring in there of some sort. I don't know why we did that, but we did. Right, and then down to the switch and back to the light bulb. So if we close the switch now, the question is what's going to happen?
D. The bulb won't light up.
Oh, well, you guys sound pretty certain about that. You're saying D, it won't light up at all.
No.
Why?
Because the plastic is an insulator.
Yeah, it can't conduct electricity.
All right, so the plastic can't conduct electricity. So what we have is we have For this light bulb to light, we have to have electrons coming out of the battery, going through the light bulb and back to the battery again. We have to have a complete circuit. And what you're saying to me, which is correct, right? If I put this plastic ring in over here, which is not a very good conductor of electricity, right? In fact, it doesn't conduct electricity at all, then there's no way for the electrons to come out of the battery, go through the light, and then back to the battery again.
Yep.
All right. Next question. Bernard, this one's yours. I know you like frogs. So.
Some stages in the development of frogs are shown below. At approximately what date in the development of the frog would you expect it to be in the stage shown below?
Okay, so we got different stages of development of frog. Over here we have an egg, then we have a tadpole, and then we have a little froglet. It's developed some legs. All right, it's got these 4 legs. He's got it part of a tail. Then the legs get further developed, and he gets more spots. The tail gets shorter, and then finally over here we got a full-grown frog. Now the question is, what day? And there's a timeline down here, right? Day 1 all the way up to day, what is it? 33, right? So it says, okay, what day would you expect the frog to look like this? He's only got just the front legs. He doesn't have the hind legs developed yet. He's got a pretty good sized tail. So what day would that be?
C, day 12.
Day 12?
Yeah, because it's in the middle between.
So it's somewhere in between here and here, right? So we could be 11, or it could be 13, or whatever. But 13 is not one of the answers down here. So the one that comes closest to 13 would be what?
C.
BC would be 12. All right, so now, they could ask you a similar question to this. This question won't appear on MCAS again, probably, but there'll be another question. And basically what it is you're interpreting this timeline, right? It could be about frogs. It could be about anything, plants growing, full moon, when does it occur?
The phases of the moon.
Yeah, the phases of the moon. It could be anything. And basically what you're doing is you're analyzing this timeline against the development of the frog and making some predictions. Right? Like any good graph, what graphs are for, the graphs and charts that you've been making, are making, really what they're for is making predictions of what's going to happen. Right? So, now then, let's go to the next one. Oh, you're going to like this one. This one's got to do with cars and trucks and things. David?
Yeah, based on the illustrations, which of the following vehicles will likely produce the least drag?
Okay.
Think
Yeah,
think A.
I think it's B.
No.
No B.
I think it's A
You think it's A?
because it's more aerodynamic. I think
It's more aerodynamic. That's a big word. What's aerodynamic mean? Right?
it's like easier
airborne.
to like move through
Air.
Move through the air, okay, and what makes it easier to move through the air is
its shape.
less the shape and the less drag, right?
Yep.
Yeah.
All right, well, you're absolutely right, Bernard. It's A, right? And, and it's more aerodynamic. It's airflow. What causes the drag is the turbulence behind it, right? And if we take this SUV-looking machine down here, right, the air comes up over the top, comes down here, and it can't follow right straight down the back. It comes off and goes down in this direction, right? So you're going to have some turbulence back in behind the vehicle, right? And that's going to cause drag. Same thing with this pickup truck we have over here. You're going to have some turbulence behind it because it doesn't slope down enough in the back. This little sports car looking kind of vehicle, it comes up nice and smooth, tapers off in the back.
It looks like a wing.
It looks like a wing, right?
Yeah.
And wings are designed
To
Make it
fly.
fly.
to fly and
To
with minimum amount of drag. And if you look at an airplane, right, it's pretty big in the front, all right, and it's sort of shaped like the wing because when it comes back to the tail section, what happens to it? It gets smaller, right?
Yep.
And that's to reduce the drag. All right. This one's Bernard's.
Which of the following graphs represents a train moving at constant speed? A, C, B, or D?
All right. So we got a train moving at constant speed, or a car, or whatever, some kind of a vehicle that's going at a constant speed.
B.
That means it's like going at 50 mile an hour.
And
right?
stays at
Constant.
50.
Yeah.
It's constant. It stays at that speed.
So it's B.
So, but that's it's B. I mean, you're
Yep.
right. Well, what's this one say?
It's going a little bit fast, then it drops the speed.
Yeah.
Orange.
Okay, it's accelerating, all right, here. Then it's decelerating, the speed is dropping off, right?
Yep.
Because the distance is changing, right?
Yeah.
Where this one down here, what about this one? What about D?
It starts slow, then it starts accelerating, then
Right, it's starting real slow because as we move along in time, right, the distance doesn't change very much. Over here, when we get out to this part where it moves along in time, the distance changes pretty rapidly,
yeah,
right?
this is kind of realistic about how car goes.
All right. What about this one?
It drove a certain speed, then stopped.
It's driving.
Yeah, it stopped, right?
Yeah.
Because as long as the time can sit there changing, and the distance is still in the same spot, right? So, all right, it has to be this one, right? This one is a constant speed, straight line, right? And as time increases, the distance increases proportionally. You guys are good. Good on MCAS. Whose is this one?
David's.
Yeah.
All right,
The
Dave.
diagram below shows a compass and a magnet. Compass magnet. A magnet is held near a compass shown above, which shows how the compass will look if the magnet's poles were reversed. A, B, C, or D.
All right, so A, B, C, or D. Which one do you think it is?
Think.
Since the thing goes on north, since the compass points on north because of magnet, it's on the north, so south and north.
Okay, well let's
Right, this one.
look at it a minute, right? You think that one?
Yeah.
I think it's either C
Yeah.
Right.
or A.
Let's talk about the compass
C.
for a little bit.
Oh yeah.
Right, this little needle. What?
C.
You think C?
Yep.
Yep.
Okay. All right. Very good. That is the right answer, right? But let's take a look at and see why it is. All right. This little needle we have on the compass is really a little magnet, right?
Yep.
And it has the north and the south pole, just like the magnet we're using over here, right? And what do we know about magnets? Opposite poles
And
attract one another, and like poles are going to repel.
yeah.
Okay, so in this picture, right, we have a north pole here on our magnet, and that mean that this is really a south pole on our compass here, because they're attracting, they're pointing to one another. So if this is a south pole, and I turn this one around, right, so that the south pole is here, and this south pole, what are they going to do?
Repel.
We're going to
Repel.
repel, and it's going to point off in this direction, right? Unless your compass is broke, it won't
Yeah,
do this, all right? All right, so C is the correct answer. Okay. What's the next one? Well, we're doing a whole bunch of different ones, right?
Yeah.
On the MCAS, usually they're sort of grouped together so that you have like kinds of questions.
the diagram below shows a food web. If the corn and oats are completely removed from the above food web, which of the following would be the most affected?
All right, now, first of all, let's explain. Those people out there watching this, a lot of them don't know what a food web is. So what's a food web? What's that? This is the diagram, which is the food
A
web.
diagram that explains the eating habits and like.
Eating habits.
Um,
What eats what, right?
Yeah.
Right? So in this particular case, we have down here, what is this? Grass, right? And up here we have
Rabbits.
rabbits,
Yep.
and rabbits eat grass, all right? What else eats grass?
Grasshoppers and
Grasshoppers.
crickets.
Grasshoppers and crickets. What eats rabbits?
The hawks and
the
owls.
hawks and owls.
All right, what eats the grasshoppers and the crickets?
The snakes and raccoons.
Snakes and raccoons, right? Down over here we have some corn and oats. What eats corn and oats?
Grasshopper and crickets. And
Grasshopper.
mice and rats.
Mice and rats. And what eats the mice and rats?
Snakes and raccoons.
Snakes and raccoons.
Nothing
Okay.
else
Hawk and
the
owls.
hawks. Hawks are the kings of it.
All right. So now then, the question was, what is the question again?
Which one of these things would be affected the most if the corn and oats are removed?
Okay. If we took the corn and oats away, Which one is going to be affected the most? Which
A.
one's? A?
Mice and rats, because that's what they only
Eat on.
because they only feed on the corn and oats.
All right, and
So do the
according to this
grasshoppers.
food web,
But the
right?
grasshoppers feed on grass too.
Yeah.
So they still have food.
Right. Right. According to this little food web diagram, right, the only thing that mice and rats eat are corn and oats.
So they rely on that.
So they rely on that. So if you took the corn and oats away,
There would be
Yeah.
no mice or rats.
they're going to starve to death. Right? Would that affect? Would that affect snakes and raccoons?
Yeah, it cut their food supply by half.
Cut their food supply by half, right?
Because
Because
they won't have
they
the
still have
mice.
another food supply, which is grasshoppers and crickets, but
They won't have the mice.
they won't have the mice and rats.
And the hawks and owls would be affected too.
Right.
Because they won't have anything else.
They'd only eat the rabbits.
Oh, you guys are good on this food.
And the
web, right?
mice.
So this is important, right?
Yep.
Because depending on what we do to our environment, right, we could kill off
One of them.
one of them, right, just by removing one of the food sources, right?
Yep.
Or removing their habitat. Ready for the next one?
Yep.
Let's do the next one.
The maps below show the positions of two continents at two different times, Africa and South America. The movement of two continents as shown may best explained by magnetic volcano eruption, B, magnetic changes, C, coastal flooding, D, plate tectonics.
Tectonic.
Tectonics. Okay. So what we have is we have two diagrams here. One showing this is South America and this is Africa, right?
Yeah.
Yep.
And they sort of fit together if you were to take them
Like
and
a
put them
puzzle.
Like a puzzle.
like a puzzle, right? And that's at one time that's what the scientists think there was their location, right up close to
Pangaea.
them, right? But now then, we know that South America's over here, Africa's over here, and we got the Atlantic Ocean in between them, and so they must have moved. And what caused them to move?
Plate tectonics.
Plate tectonics.
Plate tectonics. Okay, our continents are on big plates,
Yeah.
which are constantly moving, right? And what happens is
They rub
Yes.
together.
they rub together,
Like an
right? And one
earthquake.
goes down underneath the other one,
other.
like this. And sometimes
They separate.
one of them gets caught like this, right? And just starts to bend down, right? Bends down, and we build up a lot of stress, and all of a sudden it goes.
It's
What
separate.
happens?
An
It
earthquake.
goes away,
Hmm?
Wouldn't it cause an earthquake?
It causes an earthquake,
and
Right.
it goes like separates from one.
right? And it causes an earthquake. And if this is out underneath the ocean,
Causes
earthquake is going to cause what?
the lands to move.
Yeah, right, so they're going to move, right? Because the two
Of
tectonic.
course, the flooding also of floods.
We just had something very terrible happen.
Thailand. down
Yeah.
there.
What happened?
The tectonic plates moved and caused like a giant.
Tsunami.
Tsunami, right? A giant tidal wave that come in and wiped out a lot of people, right? And that's basically what happened is one plate was moving down underneath the other, which they normally do. One of them got caught, right? Caught, and it kept bending, and finally the stress built up enough that it went like that, and when it did, right, we had an earthquake, which caused the ocean water to come up, right, and generate that big tsunami wave, right, which wiped out a lot of people. So now then, so we know the correct answer here is what?
D.
D?
Plate tectonic.
Tectonic plates. All right, let's go on to the next one.
The pull of gravity on Earth is a direct result on the A, mass of the Earth, B, magnetic field of Earth, C, rotation of Earth on its axis, D, weight on Earth's atmosphere.
All right, gravity, the thing that holds us down to the floor here, keeps us from flying off the Earth out into outer space somewhere. What causes that?
Magnetic.
Okay, you probably haven't. I know you're starting a new kit on properties of matter and so forth. And one of the things that you're going to measure is mass. Right?
Oh, so mass of that.
Mass is the correct answer for this, right? what the gravitational field is controlled by about how much mass you have, right? And one of the definitions for mass is the amount of material, right? So like David, your head has a certain amount of material in it, right?
Yep.
And Bernard's head also has a certain amount of material. And so your head has some gravity.
Yep.
Bernard's head has some gravity. So guess what? The two heads are trying to go together like this. Right? But you don't have much mass here, right? And you don't have much mass, so the attraction between your two heads is very, very weak. Right? So you can resist that, right? But the Earth, right, has a lot of mass, and it has a lot greater gravitational pull. Right? So if we were to take the mass of the Earth and we were to increase it, like if we go to one of the other planets which has more mass, or go to the Sun, which has a lot more mass, the gravity would be a lot more, right?
What about the moon?
The moon,
Has no mass.
that moon has mass. It's got some material in it, right?
Yep.
And if you went to the moon,
There
right,
would be.
it has about 1/6 of the material that we have on Earth. So if you weighed, how much you weigh here?
About 120.
You weigh about 120, right? If we took you to the moon, you would weigh 1/6.
That's
So
20
it's-
pounds.
Yeah, it'd be 20 pounds, right? Right, because the moon has less mass, and what we're doing when we weigh you is actually measuring the force of the Earth on your body, right? And we take you to the moon, and we were to weigh you, well, we were measuring the force of the moon on your body. Right, so anything that has mass has some amount of gravity, right? But the amount of gravity that it has is dependent upon how much mass it has. The bigger the mass, the more gravity. Less the mass, less the gravity. Alrighty, let's go on to the next one.
Oxygen and sugar are products of A. Cell division, B. Digestion, C. Photosynthesis, D. Respiration.
All
I
right,
think it's C. Photosynthesis.
you think it's C,
Nah.
right?
No.
Nah.
What are products?
Made of. I mean,
Like
made
Something
from.
something that's made, right?
Yeah.
So oxygen and sugar, you're saying, are made because of what? C?
Yeah.
Photosynthesis? What's that have to do with?
Nothing.
Nothing.
No,
Okay.
don't tell me nothing.
Oh, because the plants make this.
Use carbon dioxide and, make
make
oxygen.
oxygen.
Yeah, they take carbon dioxide and water, and they make oxygen, and they
They make sugar.
maple
sugar.
syrup and stuff like
make a syrup and stuff like that, right? So,
from maple trees.
so yeah, like maple trees, right? Or like corn or whatever, corn syrup or sugar cane.
Yeah, sugar cane.
Yeah, right. So, and the sugar cane makes sugar because of photosynthesis. Right. Cell division is how the cells multiply, all right, or reproduce themselves. Digestion is what?
Yeah.
When
That's using the food, turning the food back into energy again. And respiration,
respiration is breathing.
breathing, all right? And the plants do that too because they have little holes underneath the leaves, all right, and they get dispersed water. So the answer to this question, everybody knows, is
C.
photosynthesis, right? We can sort of eliminate all the others. All right, what's the next question?
Which best describes transportation technology? A. A system that is used to move people and products. B. An enterprise that changes raw materials into goods. C. The building and finishing of structures. D. The conversion of mechanical energy into heat energy.
A. The system of.
A.
A?
Yeah.
You think it's a system that's used to move people and products? Right,
Yeah.
transportation technology?
Yep.
Right, transportation technology is like airplanes and cars and trucks and trains and
Boats.
spaceships and all that sort of stuff, right? So you're saying it is what again?
A.
A.
A? All right, well, let's take a look at the rest of the answers, though, before we go on, all right? B, is it an enterprise that changes raw materials into goods?
That's
Like
recycle. That's like making gold and
Making,
refining gold.
refining gold or taking iron ore and turning it into steel, and if we take the steel and we turn it into what?
Like,
Automobiles, airplanes,
yeah.
right? So that's like a manufacturing process, right?
Yep.
It'd be manufacturing things, or making things, building things, right? Building and finishing of structures,
Like
like, you know.
construction work.
Construction work, right? Building the new high school down here, right? So that's construction work. It has nothing, well, transportation technology has something to do with it because, what?
Transporting all the goods there. And
We gotta, yeah, we gotta get all the goods there, all right? All the building materials have to get to the high school. Same thing with up here with the manufacturing in B, right? Transportation technology is very important because if you're going to manufacture automobiles in Detroit, for instance, right? Detroit doesn't have a lot of steel mills. They gotta get steel from somewhere to manufacture those cars. And how does it get there?
By transportation.
By transportation, right? So,
But yeah,
but it's not, if we're
No.
manufacturing things, it's not transportation, but it is dependent upon transportation, right? Conversion of mechanical energy to heat energy.
That's-
like electricity stuff.
Yeah,
huh?
that's like
Almost. Like that one.
turning electricity into other
Well, let's do this,
friction.
right? That's mechanical energy, right, that I'm doing?
Yep.
And a friction is a mechanical thing, and what's happening?
Friction.
You make it
Friction,
heat,
what happened to your hands, so when you do that?
hot.
It
They get
warms
hot,
up.
right? So, and if we take like a paper clip, you ever done the paper clip and twist it and twist it and twist it and
Oh, it
twist it until,
breaks.
Yeah.
and it breaks, but what happens to it in the
It
meantime?
gets so hot.
It gets hot, right? Because you're taking mechanical energy by twisting that paper clip and turning it into heat energy. All right, whose question is it?
This one. When igneous rocks is changed into metamorphic rocks, which form of energy is this process? A, heat, B, chemicals, C, magnetic, D, light. Either.
All right, let's go to let's skip that one for a moment. Let's go to the next one. Just so we know what we're talking about. Just put that one aside. Go to the next one.
Rocks found on Earth are classified as sedimentary, metamorphic, or igneous based on A, whether the rocks were found, B, how the rocks were formed, C, the composition of the rocks, D, the color and shape of the rocks. I think it's
See,
C,
B.
B.
B?
Or
B.
to C.
You think it's B?
Yeah.
All right, B's right, right? And it's based on how the rocks are formed. First of all, the sedimentary rocks. Have you had these before?
Yeah, in catastrophic events.
Okay. It's catastrophic events, you had that, right? So sedimentary rocks, how do they form?
Like, is that the one that has other rocks put together and stuff?
Yeah, what it is the other rocks, right?
Form one rock.
They decompose some way, either that, the expansion and contraction because they get hot and cold, or the wind erodes them a little bit, right? And all those little rock particles usually go down the stream, right, in the water, and they settle out. When the water stops flowing, they sort of settle down, right? And that's what we call sedimentary, right? And if you leave them sit there long enough, they pack together,
And make
right?
rocks.
And make rocks, right? What about, what's the other one?
Metamorphic.
Metamorphic? Let's go to the next one. What's the next one?
Igneous.
Igneous, right?
Igneous.
And what are those? How do those form? Remember those?
Not the volcano? No.
You got it.
Volcano. From
Volcanoes,
lava.
right? From lava, right? What they do is to take all the volcanoes get very, very hot, and the lava, right, is all that material which gets molten, turns into like a liquid, right? And will get the lava flow out of the volcano. When it cools down, what happens? It turns back into a solid crystal, and you get the igneous rocks. Metamorphic, what about those?
Metamorphic? Metamorphic. That sounds like it changes from another rock to
Yeah.
All right, it is change, right? That's what it means. You go back into the Greek, right? And it means it changes, right? But how are those formed?
From
All All right, the igneous rocks, all right, they're heated up and they're under a lot of pressure, right?
Yeah.
And it causes the material to turn into basically a liquid. All right, metamorphic rocks are generated also by heat and pressure. Right? Maybe they take some of those igneous rocks or some of those sedimentary rocks and put a lot of heat and a lot of pressure to them,
And they become
and they become metamorphic. All right, the difference between metamorphic and igneous is
it's not just
formed from
lava.
molten material. Metamorphic doesn't never melt, right? It stays a solid. Okay, so what's the correct answer there?
For
how they form.
How they're formed. All right, so now let's go back to the other question. Back to this one. All right, what's this one?
A, the answer.
Right. When igneous rocks is changed, it's A. Now the answer is pretty simple, right? When the igneous rocks, read it to me.
when igneous rocks is changed into metamorphic rocks, which form of energy is this process? A, heat, B, chemicals, C, magnetic, or D, light?
Right? Heat. Right? Heat is the correct answer. We just covered that. Okay, let's
Yep.
do the next one. Who gets the next one?
David.
All right, David, you're up. Nice and loud.
Which of the following diagrams represent a solar eclipse? A, yeah, I see that.
You think A is going to do the solar eclipse?
No.
All right, so we got A is we got
This
the
one.
sun here, this big black looking thing. Here's the Earth, and there's the moon. Right?
This one is gonna see.
It's C.
You think it's C?
Yeah, because
Right? Because what happens during the solar eclipse?
The moon blocks the
sun.
sun.
The moon blocks the sun, right? So if I took, and here, you're the sun, right? And I put the paper up here like this, right? And this is the moon. It's blocking you out. I can't see you. If I put it over here somewhere, I can see you. I put it around behind me, or I put it off over here, I can still see you. So it's got to, the moon's got to between the Earth and the sun for it to be blocking it, right?
Yep.
You didn't like that one. You got rid of that one real quick.
Yeah.
You're moving on. Okay.
Which of these is not an instinctive behavior? A,
What's an instinctive behavior?
like,
Something that comes from instinct, like
Yeah.
just
You don't have to learn it, right?
yeah.
Okay, so something comes from just something you do because of it. You don't have to learn it, right?
A,
You sort of inherit it, right?
A bird building a nest. B, a turtle burying its eggs. A bear hibernating
hibernating.
in the winter. A horse pulling a plow.
D.
It's D. I mean D.
Why do you say it's D?
Because you have to teach a horse to pull a plow.
Yeah.
It doesn't do that.
Huh? Horses don't plow fields all by themselves?
No.
You have to teach
people.
them.
Yeah.
You have to teach them to do that, right?
Yep.
We don't have to teach birds to build a nest. We don't have to teach turtles to bury their eggs. And we don't have to teach bears to hibernate. But horses, if we want them to plow a field, we have to teach. All right, let's go on to the next one.
On the food web.
We're back to another
Food
food web. We done this one before? No, we haven't done this one, right?
Yeah.
All right, let's do this one.
David.
David, it's your turn. Don't go
Yeah.
to sleep on us just yet. We're almost done.
Which list contains all the consumers in the food web? A, grasses and shrubs. B, grasses, shrubs, grasshoppers, mice, rabbits. C, hawks and foxes. D, grasshoppers, mice, rabbits, birds, hawks, and foxes.
D.
D? All right,
Yep.
what do you say, D?
Because it
Because
has all of them.
they all eat
They all depend upon
They're gonna.
the
on the
produce,
grasses and
the
the
shrubs.
shrubs, right? Grasses and the shrubs in our little food web that we have here are not consumers.
They're
They're producers,
producers.
right?
Producers.
Yeah.
And all plants are producers, right? Because
Yep.
what do?
Produce-
Photosynthesis.
They
They
make
make
its
their own food.
They make their own food. So, right. So, but everything here is dependent upon
The grass and
grasses
shrubs.
and the shrubs, and they consume something. Either if they don't consume the grasses and the shrubs directly, they
They
consume
consume-
something that's dependent.
It depends on the grasses and
grasses and
shrubs.
the
Picture below shows the sun, a stick, and the stick's shadow. On a clear day at 10 a.m., the stick casts a shadow as shown in the picture. At 3 p.m., what will happen to the shadow made by the stick? A. It will disappear. B. It will look the same as it did in 10 a.m. C. It will be in the same position but shorter. D. It will be in a different position.
Yeah, because the sun will be in front, so it'll be in a different position.
So,
Yeah.
right, so what's happening is the sun is moving, right? Or
Yep.
in relative to the Earth, actually. The Earth
Earth
is
is moving,
right,
yes.
the Earth is rotating, right? But it appears the sun is moving across the sky. So the shadow is going to move, right? It's going to be in a different position. What if the sun were right directly over top?
There would be no shadow.
There would be no shadow,
Oh,
right?
pretty short.
Or it would be really, really very short. Okay, and what time does that happen?
12, no?
12 noon, right? So, okay, so that, there, you've got that one, and we're back to where we started from. And we had a whole bunch of different subjects that we tested today, right? MCAS questions. And the basic idea behind it is you got to read the question very carefully. You got to look at all the answers, and reach back in your memory banks, because you've all had all this material before, and decide which answer is correct. And we're wondering right now how many parents out there got all of the right answers for today. Right? So what we're doing is, this gives us no doubt, right? And if we do what, if we want to raise the pitch, we do what?
We
We
add
add
water.
We add water. We want to lower the pitch?
We
We
pour
add
out some
some
water.
water.
Okay. What if, this particular question, what if we heat the water up?
The water would
The water would boil or